Okay, good afternoon. Today we are going to talk about the first exam that will take place on Monday, September the 27th, which is next Monday. And it's going to be here in the classroom, so make sure that you are physically present here in the classroom on Monday so you can take the exam. So today we're going to go over the review, and essentially what we are going to talk about today is about the format of the exam and also the type of questions that you should expect, and also the lectures that are going to be covered, topics that are going to be covered, and then I have some problems just for discussion. Problems coming from the homework. So I want to go over those problems in case you have questions. We can answer those in class today. And that will be the end of the review session. Okay, any questions before we get started? So the time, you will have 80 minutes to work on the exam. That will be more than enough to finish the exam. Typically, I design the exam for 65 minutes, so you will have that 15-minute caution to work on the exam. And the exam has two sections or two parts. The first section is a multiple choice questions that we have 10 questions, multiple choice. These are questions that are based on the material in terms of the concepts that we cover during the first part of the semester. Like definitions, different type of charts that we have discussed, when to use those, from-to chart that we cover, when do you use a from-to chart, what is an activity relationship chart, and so on. So make sure that you understand what those are. Also, learn about the difference between the algorithms that we discuss in class, which ones are construction type, which ones are improvement type, what is the difference between those type of algorithms. Remember, improvement means that you start with an initial design and you're trying to improve that design. A construction algorithm is one that you're going to use when you're basically having an empty facility. You're starting from scratch. So those are major differences. Also, we can classify algorithms in terms of the type of data that they use for the input. So quantitative, qualitative data. So what are the different diagrams that represent data qualitatively? What are the different diagrams that represent, like the from-to chart that is used to represent the quantitative data in terms of the flow? So those are the type of questions that you should expect in this first part, the multiple choice. And then section number 2 for problems. This could be mathematical, like most of some of the problems in the assignments. Also, there could be the application of some of the algorithms that we have discussed. For the craft algorithm, as the one that we discussed on Monday, show you that it's a long process, right? So I'm not going to ask you to solve the whole thing, but I can ask you to complete a part of the process. So you need to understand the algorithm in order to solve that question. I can also ask you to compare different type of algorithms, or compare, like in terms of a question, it could be a discussion question that based on what we have discussed, tell me the difference between these two, or when would you apply this or this method, and so on. So those things should be clear. In terms of the lectures that we cover, so one more thing that I want to say about this second part is questions should be similar to the ones that you saw in the assignments, and in the questions that we solve in the labs, and the questions that we solve in class. So if you go through those problems, you feel comfortable solving those problems by yourself, then I believe that you should be in good shape for doing very well in the exam. So make sure that you go through the assignments, the labs, and the problems that we solve in class. If you feel that you are able to solve those problems without major issues, then you should be very well prepared for the exam. So what are the lectures? Which lectures we cover? We went through 1 through 3. So in the first lecture, we talk about the difference between product process and schedule design. That was our first lecture. So we went specifically and talk about each one of them, and then we transitioned to facilities design. Lecture 2, we talk about flow and activity relationships. So talk about flow systems, material flow systems, departmental planning, layout type based on material flow systems, and also we introduce the activity relationships. And then the last part that we cover in this first part of the semester was the layout planning models and design algorithms. So we discussed different ways of planning for the layout of the facility, the graph-based algorithm, the craft algorithm, and so on. So understanding those basic layout types, layout procedures, and algorithms approaches are part of the material. And that will be the last lecture. So it's not a lot of material. Well, there's a lot of information there, but just 3 lectures. One of them was split in 2 parts, which is the last one. In order to prepare for the exam, if you have the book, you can go through chapters 2, 3, 6 of the 4th edition, just for, I mean, if it's not necessary, but if you want to get more information, you can do that. But if you study the lectures, the lecture slides, the labs, and the homework, the assignments, you should be fine. Everything is posted in Canvas, so you will have access to, you have access already to the lectures with the notes, the video lectures, and the assignments with the solutions. I know there's an assignment that is due today, so I will post the solution after the class, and everything will be available. So I will remove all materials by the time of the exam. So not remove, but make them unavailable, and then those materials will be available after the exam again. So at 3:30, 3:25, you'll see that those will become inactive, the modules. In terms of the exam is closed book and notes. There's no need for a formula sheet, so you don't need to bring a formula sheet. You can bring a calculator if that makes you feel more comfortable. But cell phones are not allowed. If you need to do some computations, you have to bring a calculator. Clearly show your work and all formulas using your solution. In case you don't get the right solution, if you show me your work, I can give you partial credit. And I can easily identify when you went wrong. If you just show me the final solution and it is wrong, then there's not much that I can do to help you. And if you just show me the final solution without any work, then I will get suspicious too. So make sure that you show me that you know how to solve the problem and how do you got to your solution. Again, you will have enough time to work on the exam, so make sure that you put on the work, and that will help you in terms of getting partial credit if the solution is not correct. Questions? Okay, so I'm glad that's clear. So what I have for the rest of the review, I brought some questions. Just selected these problems from the assignments just to make sure that you understand how to solve these problems. We spent time solving a problem like this one in class. We have a process operation with 4 stations here. One of them is a rework operation on parts that fail in the inspection upon completion of operation 2. And we want to know how many units must be processed start with in order to meet the required output of 5,000 units. So the only difference, I mean, we solved many problems like this one, but the major component, I will say the major difference between this one and the other type of problem is this loop right here. So we are not letting those units that are discarded to go to waste. We are bringing them back to, or part of them, bring those back to the process. So in order for me to compute what's needed here, input of 1, in order to get this output, I have to take into account everything that is happening in that process. So we solve this problem working in reverse. I think I showed you how to get to this final expression in class. We worked the problem from the beginning. And essentially what we are trying to, if you remember, we are trying to get an expression that only uses the information that we have available. So in this case, if you look at the diagram, the only data that we have available is the percentage of the parts that are discarded. So D1, D2, D3, and D4. And the other piece of information that we have is the output. So in this case, this is O3. Okay, so we want to find I1. I don't know I1. And the only information that I have available is D1, D2, D3, and D4, and also O3. So the idea is I will build an expression that only uses these parameters. And at the end, I obtain I1. So we start looking at the output of each one of the stations, and we can show the formulas for those. So for O1, we know that what we're going to get is what's not going in this direction, right? So that's the input of 1 times 1 minus D1. And we know that that's going to be equal also to I2. So if you obtain O1, that's going to be the same as I2. In the same process, we can find O2. So O2 is going to be equal to whatever is not going in this direction. So I minus D2 times 1 minus D1 times I1. So I times 1 minus D1 is what we are getting in. So we are multiplying that by this amount that is not going in this direction. And we can continue that process, finding those expressions for each one of the inputs and outputs. And we spent, I mean, I don't want to go through the whole process now, but we did this in class. We solved step by step. So if you go back to the lectures, you will see the process step by step until we get to this expression right here. Okay, so the idea is after substituting these parameters into this equation for O3, we can solve for I1. We can solve for I1 and then substitute the values for the parameters that we have available and obtain the number of units that are needed to get the 5,000 units at the end of the process. So my question for you is, well, not a question, but is there any major concerns about how to solve this problem? Hey, there's any, I mean, if you go back to the lecture, you'll see that is developed, the expression is developed piece by piece in lecture 1. And it's the same problem. The only difference now is that we have numbers to input into the expression. And on the next problem, we did multiple examples like this one. This process looks like this. We have machine 1, machine 2, machine 3, and I believe the challenge for this type of problem is to make sure that you come up with the right representation. Once you get the right representation, the process is quite simple. So we have a machine, a part that uses machine 1 and machine 2. So part A is produced on machine 1 and then on machine 2. So that will be part 1. And 1 unit of part A is assembled with 3 units of part B, which is produced in machine 3. So from here, we get this connected to that assembly process, and we know this is going to be 3 times. So I need 3 parts. Of this one to make 1 assembly. So from A4, we go to, we get M5, parts from A5. And this is the final step of the process. So machine 1 has a scrap factor of 20%. So B1 is 0.2. Machine 2 has a scrap factor of 10%. So B2 is 0.1. The assembly process, has a scrap factor of 15%. So B4 equals 0.15. Another part C is produced on machine 5 and has a scrap factor of 0.25. So B5 is 0.25. Part C and the sub-assembly compression assemble. Assuming machine 3 has an assembly station 6 have a scrap factor of, okay, so this one, D3 is 0.3 and D6 is also 0.3. And so we have all that information. We have the scrap factors and we want to estimate our input for each part type. So for part type A, we need to find out what I1 is. And we know that for that sequential process at the top, we can do the output of station 6 divided by the scrap factor of the stations that are in that sequential process. So that includes M1, M2, A4, and A6. So it's O6 divided by 1 minus D6 times 1 minus D4 times minus 1 minus D2 and times 1 minus D1. Total after rounding is 35,000. Now for I3, which is this part coming in here, we have to remember that we have to multiply that by 3, which is why we have this factor. We need 3 parts of this type of part to be assembled with I1 or the machine's part type A. And this is going to be equal to the input of 4 divided by the scrap factor of that machine. So the question is, how do we find I4? So if you remember what we just did for I1, instead of going through the whole process, we'll stop at before A4. So we're going to consider the scrap factors of A6 and A4. So in this, should be 1 and 1D3. This should be D4, sorry. So it's going to be O6 divided by the multiplication of 1 minus D6 times 1 minus D4. So D6 is 0.3, D4 is 0.15. So that's why we get 15 divided by 0.70 times 0.85. So that would be I4, 25,210. So now that we know I4, we can substitute that into this part of the expression. And we will get 3 times 25,210 divided by D3, which is 0.70. 1 minus D3, I'm sorry, which is 0.70. And that will give us a total of 108,043 units. And finally, we got to I5. So I5 is going to take into account the scrap factor of A6 and the scrap factor of M5. It's going to be O6 divided by the multiplication of the 1 minus the scrap factors of each, or multiplication of the 1 minus the scrap factors of station 5 and 6. And that will give us these amounts. Okay, so make sure that you catch this was a typo. You see the solution, that should be D4. But the rest is correct. Questions about this one? Yes, sir. So this right here, this number, yeah, it should be 4 instead of 3. Okay, because you take into account this station and this station. Station A4 and station A6 in order to get I4. So in this problem, we don't have rework. So that's the major difference between this one and the previous one. In the previous one, we have rework. In this one, we have no rework. What we have next. Okay, so this one we did. I think this is coming from the homework as well. We did a couple of examples in class, and then we also had a lab. This problem is coming from the problems in the assignments. And we have data for a local wood manufacturer that wants to decrease material handling by changing from a process layout to a GT layout, or cell manufacturing layout. It is considering installing a conveyor for intracellular movement of parts. It wishes to restrict intracellular movement. The machine part matrix of the wood manufacturer is shown below. And the problem asks you to use the direct clustering algorithm to form the cells, and if conflict exists, propose alternative approaches for resolving those conflicts. If you remember, you start, your data is given here. So what this is representing is for part 1, this has to be processed by machine 5 and machine 6. Part 2 needs to be processed by machine 1 and machine 4, and so on. So that's the data that we have. So the question is, using this direct clustering algorithm, can we separate this into different cells? And if that's the case, which machines will be together to process which parts? And we can get that information using this algorithm. Okay, so first thing we're going to do is to look at the totals for the columns and the rows. So that's the information that we have here. These are the totals for the rows, and these are the totals for the columns. So after getting that information, now we start the sorting. We're gonna sort the rows first in descending order. So that's what we start with 2 up to 1. For the tiebreakers, we are using the number of the row. So the highest number goes first, and then the other ones will follow. So we get 8, 7, 6, 4, 3, 2, 1, and then 5, which has a total of 1. And then we do the same for we start sorting. After we sort the rows, we sort the columns. And for the columns, we are going to start with the lowest number, and then we'll move to the right to the largest number. So the complete sorting process is that table here at the top. So this is after sorting both the columns and the rows. So at the end, we have 2 here. We have 2, 2, 2, 2. 1 is 3, and 6 is 4. Okay, so, and then the sorting here is 2, 2, 2, 2, 2, 2, and 1. Okay, so after you sort those parts appropriately using the steps of the algorithm, then we can start looking at moving rows and columns. So we're going to start with the columns. We're going to start moving. We're going to look at the first row, which is row 8. And we're going to start looking at each column in this row and see if we can move columns towards the left. How do we decide that? By looking at which columns have a value of 1. Right, so the first column that has a value of 1 is 3, and the next one is 6. So that's why we have 3 and 6 moving to the left. And then we move to the next row. So 3 and 6 are now fixed, right? And now we move to the next row and we see 4 has a 1. So we can move 4 next. And then 2 has a 1. So we also move to the left. So these 2 are fixed. And the third column, we have 5 with a 1. So we put 5 after that. And then the only column that is left is 1. So that one will stay there. So at this point, we are done with the columns movement towards the left. The last step is to look at the rows. Okay, so now we're going to look per column. Okay, first we look at the rows and we move the columns. Now we're going to look at the columns and move the rows up and down. So we're going to start with this matrix. And we're going to see if in this column there's a possible movement up. The answer is yes. We can move 3 up. And that's what we have here, 8 and 3. Okay, so those are fixed. Then we have 6. We're going to see if we can move anything up. So the next one that can be moved up is 6. So 6 stays there. And 3 is already up. So the next one will be 1. So 1 will come after 6. Okay, so we move to the next column. And we have a 1 in 7. So 7 will be next. And then 2 will go after that. And then we go to the next column. What do we have? 7 and 4. So 4 will be next. And then the one that is left is 5. So at this point, we have completed the sorting. So the question now is, after you complete this process, can you split this into different cells? The answer for this one, yes, we can do that. And it is not obvious from the first time that you see it, but if you look at each column and row by itself, you will notice that you can split this 3 machines or 4 machines into a group, and they will take care of parts 3, 6, and 5. Because 5 is only using machine 6 and 1. 6 is using all of them from 8, 3, 6, and 1, and 3 is using 8 and 3. They're not using any other machine. And then the other group that I have highlighted here in yellow, they're using the other group of the machines. And that's how you split these two. So you can split this in 2 cells, and you can see which parts are belonging to this group and the parts that are belonging to the yellow group in this case. Questions? Good. So you should expect something like this in the exam. So make sure that you understand how to solve this one. And then the last problem that I have listed for the review is the one in your assignment that was due today. So it's for the Kraft algorithm. So we are given this information. Manufacturing concerns has 5 departments, A through E, located in a rectangular building as shown below. So we have the layout, and we have data for the flow, the unit cost data, and the distance matrix. All of them are given. So the first question is asking, using the Kraft two-way exchange procedure, indicate all the departments pairs Kraft will consider exchanging in the above layout. Okay, so the first thing you have to look is there's 2 things that we can consider when selecting possible pairwise exchanges. First, if they share a wall, you can consider that as an exchange or a possible exchange. The other thing is, if they have the same area, they don't have to be located next to each other. If they have the same area, they can be considered as possible exchanges. So that's why in the answer, I have looked at the areas of the departments. And I'm finding the areas based on the squares that are part of each department. So I count the number of squares, the length, and the width of each department, and I compute the area. I have the area for A 48, for B 40, for C 85, for D 40, and for E 62. Note that the area of department B is equal to the area of department D. So B and D have the same area. Even though they are not located close to each other or they are not sharing a wall, since they have the same area, they can be considered for an exchange. So when I'm listing the possible exchanging department pairs, I have to list that as a possible exchange because they have the same area. Okay, so in this list, you will see A and B, they share a wall. A and E, they share a wall. B and C, they share a wall. B and D, they have the same area. C and E, they share a wall. And D and E, they share this wall. So those are the possible exchanges. Then part B And as you can see here, I'm not asking you to solve the whole problem. I'm just telling you, show me that you know this, show me that you know this. Compute the estimated cost of exchanging departments A and B. So to compute this, we will have to know the distances between the centroids. We need to know the flow, and we need to know the cost. And that information is given. From the original information, I have this flow, cost, and distances. Now I'm considering a possible exchange between A and E. Okay, so what I'm saying is I'm going to move A here, I'm sorry, E here and A here. The way we proceed in craft is now we are basically switching the location of these departments, but we are assuming that these centroids are not going to change. Okay, so the distances, the way they're going to be affected, or distances that are going to be affected, are those associated with this swap. So if you can see here, distance for AC. So you look at where is it? So the distance between A and E, see, we're just swapping them, is not going to change. B and C is not affected by A and E, so their distance is going to be the same. So we have the same distance, 12, 12, 11, 11. B, D, they are not affected by A and C. A and E, I'm sorry. So distance with the exchange is going to be the same. CD is not going to be affected. The only two that are going to be affected are AC, because now A is going to be here and C is going to be here, so the distance is going to be changing. And the distance between D and E, because E is now here, so this distance is going to be different. And those are the only distances that we are recomputing. For AC, the distance will be 8, and for DE, the distance will be 18. So now, after recomputing these distances, I can compute the cost. So how do you compute the cost? Remember the expression, it's the double summation, I at J, Fij, Cij, and we're going to use the distances, the new distances, with the swap AE. And I have all that information here. Okay, so I'm going to go row by row. That's going to be 5 times 1 times 8. I go to this one, plus 5 times 1 times 11. Go to this one, 6 times 1 times 12, plus 2 times 4 times 22, plus 3 times 3 times 10, plus 7 times 1 times 18. Double check, return. Okay, so this should be equal to 559. So the total, or the answer, the computed cost, estimated cost of exchanging departments A and E is 559, which is the answer here. Sorry, let me move this. Okay, so we have the information is given. we do the swap and we update the distance for only the departments that are affected by the swap. Those that are not affected are not going to change distances. And after that, we just compute the cost associated with the flow, the cost for the transportation, and the new distances. Okay? So if I give you, for example, an initial cost, saying like, okay, my current cost for the current layout is $650. I ask you to do the swap and tell me whether or not this is a better layout. You will compare the cost. You will tell me, yes, it is a better layout because it's improving or it's reducing the cost. If it is more than 600, then it's not, right? So that's the idea. You compare these possible swaps and then you choose the one that gives you the best performance. Okay. And I think that's the last problem. So I just want to know, do you have any questions? Yes, sir. So it could be, well, I would not say all of them will be definition, but I will say concepts. So things that you should know when you are solving this problem. What type of information is given by this type of chart? What is the difference between construction and building algorithms? What algorithms are considered construction? Which ones are considered improvement? Those are the type of questions that you should expect. Okay. So if you go through the notes and you make sure that okay, this is what we are using to solve this problem. These are different type of algorithms. These are the type of data that is used by each algorithm. That information is what I can ask you about. So concepts. Any other question? Good. So if there's no questions, then I'll stop here. I'll see you on Monday. I will send an email just to remind everybody that you have to be here to take the exam. So I will send that email by the end of the week. So you don't forget, you have to be here on Monday to take the exam. What I'm going to do is I'll come early. I will close the door. I will set up the exams on the table. So when you come in, you can sit down on any space that have an exam. Okay, so I will do that. So I will do it before the class, so you will have all the hour and 20 minutes to work on the exam, but just be aware that I'll be putting the exams on the table before you come in. Good, so I'll see you on Monday. Have a good weekend.